Good day, class. Today we're going to continue sketching rational functions. And today we're going to look at some of the uh, lesser common rational functions. All right, so we will start here. Y equals x over x squared plus 1. And let me grab some graphs here so that all right, so now that we have our graph, we can go ahead and get going with our normal process here. So first we want to look for x-intercepts. So we set the numerator equal to 0 and solve. In this case, we just get 0. Y-intercept. Plug 0 in for x. Again, we get 0. Vertical asymptotes. We set the bottom equal to 0 and solve. But because this is a plus, remember anytime you square a number, you get a non-negative number. So if you take a non-negative number and add 1 to it, it will always be positive. Therefore, it will never be 0. So there are no vertical asymptotes. Horizontal asymptote, the degree of the denominator is larger. Therefore, we have y equals 0. If we get some extra points here, and again, we can normally do negative 10 and 10. Here we can also, do a couple of other numbers, negative 5, maybe negative 1, 1, and 5. I just picked random numbers, just kind of intermittently throughout there, not that they're any special importance. So if I plug negative 10 in here, we're going to get negative 10 over 101. Plug negative 5 in, we're going to get negative 5 over 26. Plug in negative 1, we're going to get negative 1/2. And then, of course, all of the positives will just be the positive versions of this, right? So 1/2, 5 over 26, and 10 over 101. Oops. All right, so let's go ahead and put our one asymptote here on. All right, we have our x-intercept at 0. We have negative 1, negative 1/2. Negative 5, negative 5/26. And negative 10, negative 10 over 101. And then here we just have the positive versions of the same thing. All right, so this really isn't terribly interesting at all. That's really it. Not a whole lot to it. All right, this is going to be pretty similar. All right. So we go back to our normal process here. So x-intercept, we set the top equal to 0 and solve. 32 never equals 0, so there is no x-intercept. Y-intercept, we plug 0 in for x, and we get 32 over 16, which is 2. Vertical asymptote, again, this is a plus with this squared, so none. Horizontal asymptote, the degree of the bottom is larger, so that is y equals 0. I guess we forgot to talk about the hole in the last one, but obviously nothing canceled, so there's no hole. And again, negative 10. You can just kind of pick whatever you want here. 4, 4, 10. I guess if we really wanted, we could try maybe something like negative 2 and 2. So we plug negative 10 in here. We get 32 over 116. Plug negative 4 in. 32 over 16 plus 16 is 1. Plug negative 2 in. 32 over 20. So a little over 1.5. And then these will all just kind of match up again. Of course, you can plug them all in if you want, but... Alright, so now if we go ahead and put this stuff in, just to make it a little bit easier, I'm going to go ahead and make this scale way different over here. We'll just call this 1 and negative 1. Everything else can be the same. Alright, so now I've got negative 10 and 32 over 116. Right, that's not quite 0.3, so that would be somewhere here. Negative 4, 1. Up here. Negative 2, that's a little over 1.5. So somewhere up in here. We know that we have the y-intercept of 2, which would be up here. And then all of these will just mirror back. Right, so this is going to end up looking something like this. Again, nothing terribly interesting. This is just going to be another one, except because of the negative, it's going to be flipped, so it's going to be like an upside down hill. I don't feel the need to have to go over that. Alright, so now we'll move on to this one here. Move this over here. Okay, so this obviously factors. We can factor this out, and we get x times x minus 1 over x plus 1. So, whoops, don't need to go there so fast. X-intercept, we set the top equal to 0 and solve. We get 0 here, and we get positive 1 here. Plug 0 in for x. 0 times anything is 0. Vertical asymptote, set the bottom equal to 0 and solve. Horizontal asymptote, the degree of the top is larger. All right, but this is actually something that I definitely want to talk about. All right, so we talked at the very beginning, the first day, that you could also have slant asymptotes. All right, a slant asymptote occurs when the degree of the top is exactly 1 larger than the degree on the bottom. So since this degree is 2 and this degree is 1, we will have a slant asymptote. All right. You can find the slant asymptote using either long division or synthetic division, and you have to ignore the remainder. All right. So because this is just x plus 1, this is easy to do with synthetic division. All right, so I'll put -1 in my box, and then I'm using up here. All right, so this would be 1, -1, 0. Bring my 1 down, multiply, add, multiply, add. Of course, I know I'm ignoring my remainder. So this actually tells me that my slant asymptote is y is equal to 1x minus 2, or just x minus 2. Right, of course, if we were continuing on here, the whole, nothing canceled, so there obviously isn't one. Right, we can still do some extra points here. We can do our -10 and 10. We have a vertical asymptote at -1, so we can have -2 would be to the left of it, 0 would be to the right of it. Of course, we don't need that because of our y-intercept. So if we go ahead and plug this in here, we're going to get 110 over -9. Right, when we plug -2 in, we get 6 over -1, so -6. And when we plug 10 in, we get 90 over 11. All right, so now I'll go ahead and put my asymptotes on here. All right, so my first asymptote, vertical asymptote, at x equals -1. All right, next we are going to have our slant asymptote of y equals x minus 2. So that's -2, with a slope of with a slope of 1, obviously. All right, so we should just be able to go here and do something like this. All right, so that's the line. Whoops, I'm an idiot. This one needs to come down. There we go. So that's y equals x minus 2. There we go. All right, so there's our asymptotes. Now we can put our points on here. So we have x-intercepts at 0 and 1, y-intercept at 0. We have -10, 110 over -9. So that's -10, -11 point something, so somewhere down in here. Right, we have -2, -6. So 1, 2, 3, 4, 6, so somewhere here. Let's see, -11 would actually be -9, -12, -13. So this is actually a little bit further down, and it will actually be just below this if this were extended. In fact, it may be beneficial to do that. So somewhere right in here, which means this point should be down here. All right. So then we have, of course, 10 and 90 over 11. So that's just over 8. So 10, just over 8. All right, so this line isn't the greatest, and I apologize for that. The slope is a little off, that's why it's a little bit off on here. Okay, let's try this again. All right, so 110 over -9 is -12.2. So this should not, whoops. That should only be about 13. So there's 11, 12, and a little bit more. So somewhere in here. And my line should be x minus 2. So this would be at -12. Oh, come on. There we go. Much better. All right, so now using these lines as guidelines, all right, it's kind of obvious how this graph is going to go. And similarly here. Like so. And that's it. So it looks very much like a regular rational function. The only difference is we don't have, instead of a horizontal line that guides us, right, we have this slanted line that guides us. All right, here we go again. All right, so this will factor to x minus 2, x plus 1, all over x minus 1. So x-intercepts we have at 2 and -1. Y-intercept we have at 2. Vertical asymptote we have x equals 1. Horizontal asymptote, again, we don't. We will have a slant asymptote. All right, so again, we can use synthetic division with this thing over here. So I'm going to put 1 in my box, and then 1, -1, and -2. Bring this down, multiply, add, multiply, add. Of course, we don't care about this. So this tells me that my slant asymptote is just y equals 1x plus 0, or just y equals x. And of course, we have nothing canceling, so we have no hole. All right, so now we can go ahead and put our stuff on here. So we will have a vertical asymptote at 1. We will have a slant asymptote of y equals x. All right, we will have x-intercept at -1 and at 2. A y-intercept at 2. We do need to find some extra points here. Alright, so -10 works. We have a y-intercept of 2, so 3 and 1 and 10. Alright, so when we plug -10 in here, we get 110, 108 over -11. When we plug 3 in here, we get 9, 6, 4 over 2, which is just 2. When we plug in 1, we get -2. Oh, yeah, we can't plug in 1. That's my vertical asymptote. This should be 0, which we don't need. That's 2. And then here when we plug in 10, 190, 88 over 9. Okay, so we have -10 and 9 point something. -9 point something. So here somewhere. We have 3, 2. And we have 1088 over 9, which is just under 9. So this is now pretty easy. And done. So there are slant asymptotes. Okay, so now we're going to talk about the last type of problem that you're going to see. Basically, this is going backwards. All right, it says write a rational function that has the specified characteristics. All right, so let's give myself some room over here. And I'll put these in a different order. Okay. So we know that we're looking for some rational function. Well, a rational function looks like a fraction. All right. It says that my vertical asymptote is x equals -2. Well, to have a vertical asymptote of x equals -2, I have to have a factor of x minus 2 in the denominator. To have a 0 of x equals 2, I have to have a factor of x minus 2 in the numerator. All right. Now it says I have a slant asymptote, which means the degree of the numerator has to be exactly 1 larger than the degree of the denominator. So I'm missing some term over here, some piece. It's going to be linear, so just of the first degree, but we don't know what it is. Now when I actually divide these things, like I said earlier, when we actually do them, we do synthetic division or long division. That's how you obtain your slant asymptote. So this actually equals x plus 1. Now, our final answer is just going to be the left-hand side of this equation here, all right, but with the p of x that we find being inputted in there. All right, so I'm trying to find p of x here. Well, the first thing I need to do is multiply both sides by x plus 2. So I can multiply this side by x plus 2, multiply this side by x plus 2, and over here my x plus 2's cancel. All right, well now I'm trying to get rid of this x minus 2. So in order to do that, I need to divide by x minus 2. Whatever I do to one side, I have to do to the other. All right, so now I'm left with p of x equals this. All right, however, I am going to go ahead and multiply out the top, distribute that out. So we're going to get x squared plus 2x plus x, which is plus 3x plus 2. And that's all over x minus 2. Well, I don't want my p of x to be this messy. I want it to be some nice, succinct linear function. X plus 3, 2x minus 1, something like that. All right? Well, in order to do that, I can actually just use synthetic division on this polynomial here. So I take my 0 of the denominator, which is 2, put it in a box. I take my coefficients here, 1, 3, and 2, and I do my synthetic division. Okay, again, like when we find the slant asymptote in the previous problems, we just ignore this remainder. All right, so my slant asymptote is going to be x plus 5. I'm sorry, not my slant asymptote. My p of x is going to equal x plus 5. All right, so now I can rewrite this stuff. I no longer will need the slant asymptote. I just needed that to help me find my p of x. So my actual function here, my f of x, is going to equal x minus 2, because I need a 0 of 2, so that goes in the numerator, times my p of x, which I just found to be x plus 5, over my vertical asymptote of x minus 2 tells me I have an x plus 2 down here. And you could leave it just like this. This is perfectly fine. If you wanted to multiply this top out, you could. It doesn't matter. It's the same thing. All right, don't worry about this. Your assignment will be on Delta Math. You'll have one short assignment on Delta Math. You will also be given your rational functions review. All right, go ahead and work on that. Your quiz on Friday will be much, much shorter than the review. All right, but go ahead and work on that today, which is Wednesday. I will, with the students in class, B-Day kids, I'll go over it in class Wednesday, but for those of you, or Thursday, but for those of you at home, I will be putting a video up of that as well. And your quiz will be short and sweet on Friday. Have a good day.